Okay, so good afternoon, everyone. Today we are going to look at melting and boiling. Boiling. Now, we have learned that when object gains heat, its temperature is going to rise. Right? So you give heat energy, then the temperature goes high, and we learn that temperature depends on kinetic energy. Specifically speaking, it depends on average kinetic energy. So when you give heat, the molecules start vibrating more or moving more, and the average kinetic energy increases, the temperature increases. But there is something. So based on this, we have these three categories of matter: solid, liquid, and gas, which are fundamentally different by the way they are bonded, by the strength of the bonds among them. When energy is given, yes, first it's going to be used for changing the average kinetic energy of that substance. But there comes two turning points in the story of matter where they change state. You give heat to solid, it's become a hotter solid, it becomes a high temperature solid, but still that is solid. But there comes a point where the solid becomes liquid. Okay? Where the solid becomes liquid. Imagine the rubber band again. Okay. If you have rubber band at home, please take one and try doing this. When you stretch it, the tension in the rubber band is going to increase and increase. It will be a more tense rubber band. When you give heat, it will gain kinetic energy and it will be a higher. It will reach higher temperatures, but it will still be a solid. That basic fundamental structure arrangement is not broken. When it reaches a certain temperature, which we would call as the melting point, the solid would start to melt. Okay. Now during this process of melting also you will be giving heat. Okay. You will be giving heat. But the thing is, the heat that you would be giving during this time, during the change of state, the heat that is given during the change of state will not be used for a change in temperature. You get what I'm saying? the energy that you are giving during a change of state will not be used for changing the temperature, because the energy that you would be giving will not be used by the particles as kinetic energy, as to increase the kinetic energy, but it would be used to break the bonds. It will be used to break the bonds. Okay. So what happens is, you're giving energy. So if you try to draw a graph for the temperature of that substance and the energy that you are providing, E. Let's now, it is initially at a given certain temperature. You are giving energy, its temperature is rising. But then it has got enough energy and it has reached a temperature, its melting point. And during the process of melting, you will be giving more and more energy. You are providing more and more energy. The energy value is increasing, but the temperature would still remain at the melting point. Because for the temperature to change, the kinetic energy must be changed. Okay? For the temperature to change, the kinetic energy must be changed. But during a change of state, the energy you provide is not changed to kinetic energy, but it is used to break the bonds. It is used to break the attraction between the molecules. You can imagine it like this. Now there is a box, and you are pulling it in this direction, and assume that this is a very frictionless flow. Then the work that you are doing using this force, the energy that you are giving to this box, will be used to increase the kinetic energy. The box will accelerate and its velocity would go on increasing, which means its kinetic energy will also increase. But instead of moving it horizontally, if you're going to lift the box with a force equal to its weight, okay, with a force equal to its weight, then you are still doing work, but the work you are doing, the energy that you are giving to that object, is not being converted to kinetic energy, but will be converted to gravitational potential energy. Right? So there is no condition that a certain portion should go for kinetic energy, as long as this is equal to mg. During a change of state, there is the energy that you are giving energy, but it is not being used to increase the kinetic energy of the particles, but it is used to break the bonds and to set the particles free, to make the solid the liquid, or the liquid the gas. So the energy that you are giving, in that this energy doesn't show up as temperature rise. The temperature will remain constant. The heat that you are providing doesn't show up because the temperature doesn't change. That's why we would give it the name latent heat. The meaning of the word latent is hidden. It's hidden heat. I would rather prefer the word hidden heat, because that's kind of has a rhyming, and at the same time it is more direct. So latent heat means it's hidden heat. It is hidden in the sense it doesn't show up temperature. You can't catch him by looking at the temperature. Okay. The same idea appeals for any change of state from liquid to gas as well. So once it has melted, so during this time the object remains solid. Then this is being converted, and once it has been converted, so this is solid. Now this is change of state, solid to liquid. So during this time both solid and liquid are present. A part of it is converted to liquid and a part of it is still solid. Then here we have solid, and when you give here we have liquid. You give energy, it becomes, its temperature increases. So during this state it is liquid and its temperature, you can see, it is increasing. But then again there is next turning point, the boiling. Again during boiling the bonds of the liquid are broken, shattered, and a change of state happens. During that time also the energy that you are giving will not show up. So the temperature would remain constant at the same value, though the energy would be increasing. Then afterwards you have the gas, and if you heat up the gas, its temperature will go on increasing. So it's like a kind of a staircase kind of arrangement. Okay, this is the graph is more like a staircase graph, like not exactly, but yeah, kind of. So don't start thinking like this, you would be wrong. It has a slope. Okay, so you just forget about that. Okay.